But you can start the video now.
Oh,
Start the video now. Okay.
Hello, today I'm gonna explain to you about Bernoulli Theorem demonstration. So, the materials that we need to demonstrate the Bernoulli Theorem is 40 mm pipes, 16 mm pipes, pipe reducer, valve, and 2 plastic tubes. First, we need to fill the tank with water until it's full. Next, open the valve. Then, mark the water level using or tank. Then measure the water level using ruler. So from the experiment, the pressure at tube B is lower than the pressure at tube A. The volume of water that flowing through the tubes are the same. The velocity of water at tube B is higher than the velocity of water at tube A. So the bigger the diameter, the lower the pressure. In conclusion, the higher the velocity, the lower the pressure.
Okay, pause for a while. Okay, the bullet number 2, volume of water that flowing through the tube and A and B are the same. It should be flow rate, not volume. Because it is flowing through by time. Technically, volume is not wrong, but flow rate is more accurate description. Okay, go back to the video at where I can see the whole thing. Pause at that time.
Clear video tu. Rewind pergi eksperimen tadi.
Dari sini.
Yang saya nampak.
Hah?
Yang saya nampak full eksperimen. Yang kat last, I think.
Ni.
Dia tu, dia jalan tu.
Then measure the water level using ruler. So from the experiment,
Drag to 15 seconds. Now it's 41. Drag the 50 seconds, not fun. Go back.
50.
49, 50 49. Okay, now this one. Okay, this one okay. Because it highlight the height already. Okay. So Michelle.
Yes.
I want to ask you. Okay. So on the left and right, what is the pipe size difference? Which one is bigger?
The right one.
The right one, very clear. The right one is a bigger size.
Yes.
So the flow rate passing through the two pipeline at through straw, okay, is the same. So what happens to the velocity? Which one is bigger on the left or right?
On the left side, the velocity is higher than the right side.
Okay. So what will happen if that velocity is different?
The velocity is different, then the measure of the pressure will change.
The pressure will change.
Yes.
How does it change?
Because high velocity means the lower pressure at the
No, you are answering why then. I asked how. How does it change? Bigger or smaller like that?
Because of the
Others, please mute your mic because you are creating echo now.
because of the velocity, it changes because the water travel from higher pressure to lower pressure.
Huh? No. I mean, yes, you are not wrong, but it's not in this case.
Okay.
The water path from right to left is high pressure to low pressure, of course.
Yes.
But what I mean is, what does it have to do with the water level?
The water
The what?
level.
Okay, now you say that the pipe on the left, the velocity is higher.
Yes.
So what does it affect? How does it affect the velocity? How does it? How does the higher velocity affecting the pressure on the left?
The water level is low.
No, no, don't say water level. Tell me the pressure first. What is the pressure now?
The pressure at the left will be low. Will be low pressure.
Will be low.
Yeah.
Because
Because
because we,
um be, because of the diameter.
no, because the velocity.
Because the velocity is high.
Okay.
Okay.
Bernoulli theorem says what?
The higher the pre- yeah, the higher the pressure, the lower the velocity at the
Oh.
at the
So when pressure is higher, velocity will
Yes.
change.
Yes. When pressure is high, the velocity at the tube will be low.
Okay, now I want to address to Marina.
Yes, sir.
Okay, so in Michelle just say that higher pressure will cause lower velocity. Do you agree with her?
Yes.
Why?
Because small diameter makes the pressure make I don't know. Because
You
the
don't know.
water no sir. Jap.
Okay, my concern is now, okay, which one is affecting which one? A affecting B or B affecting A? The relationship cannot terbalik, ah?
Oh, the higher the velocity, the lower the pressure.
Just now
So
Michelle said that pressure higher
so
than the
Michelle
velocity too.
so Michelle punya tu terbalik.
Terbalik, terbalik is not true anymore, ah. So Bernoulli theorem is velocity affect pressure in terbalik way lah. Then diameter will change, and then diameter change, the velocity is not called Bernoulli theorem. It is just normal case. Just what? Just science lah. No specific name for it, I think. Okay. All right. So thank you, Marina. So the next question, I want to go to Daniel.
Okay.
So now that we know
Yes,
that the pipe on the left is low pressure, so
Yes,
what happens when it is low pressure?
the level of the level of water decrease
Increase, decrease compared to what?
compared to the right side, to the level of water in the right side.
But it is flowing faster. What? It should have
Yeah.
the power to go up then.
No, sir, because of the principle, the higher the velocity, the lower the pressure.
Okay, so the water pressure and water pressure and water level here. What is their relationship? They are like proportional, or they are like inverse, terbalik?
Inverse, sir.
They are inverse.
Yes.
The pressure and the water level. The height of the water level.
Oh no, sir, as a matter of fact, it's proportional. The lower the pressure, the lower the water level.
Okay, all right. So you can now go to your experimental data presentation. I want to see experiment 2. So please tell me the calculation step, the idea of the calculation step. So means why we do step 1, why we do step 2. No need to tell me the numbers, and then start from the objective. Start from objective of experiment 2. Who is presenting?
Claire.
Oh, okay. Can present already. You mute your mic just now.
Okay. Experiment 2, the objective is to measure flow rate with Venturi meter. And here we need to find the flow rate average and ideal flow rate. And this is the calculation. Right after we calculate the ideal flow rate, we then need to find the error between the calculated flow rate, which is the Q average, and the actual flow rate, which is flow rate ideal, by using this equation.
Okay, my question is for Claire. Go to slide number 8. Where do you get that CD in the data analysis, the last one?
It's the slope.
This is what?
The slope.
Or somewhere else.
This the slope.
Yeah, I know the slope. Why suddenly you show me this slope? That slope is the CD that you obtain in experiment 1. Correct?
Yes.
So from the experiment 1, you already get the CD. Then experiment 2, you are doing something else. So can you tell me or describe me the shape or the characteristic of a Venturi meter?
The characteristic is like it has a big pipe, then it becomes smaller in diameter, and go big again.
What is the middle called? The small diameter middle? Does it have a name? Slide number 8.
The throat.
Okay, the throat. The middle one is called the throat. All right. Four of you already answered my question, ka?
Ready, sir?
Yes,
already. So my last question is to everyone who knows, just try to answer lah. Why you want to calculate the error?
To deviate
to find out
if the theory is correct or not.
Who wants to answer?
Daniel.
Daniel. Okay.
To know how much we deviate from the theory.
What theory? Which one is the theory one?
Which one is the theory?
Hey, wait. Deviate from theory.
the flow rate, the
The
ideal
flow rate theory.
Deviate from QI.
Yes.
Yes, right.
Go to slide number 10. So deviate from who actually?
Deviate from experiment.
deviate from ideal flow rate kah? Your ideal flow rate pun tak is not in the equation pun.
Atas ni.
Deviate from actual flow rate lah.
Actual flow rate, sir.
Just now you say ideal kan?
Not me, sir.
Or you say what? You say correctly kah?
No.
Yeah, it's
Alright, okay.
Mr. answer.
So we
Ideal.
want to know how our we use Venturi meter to measure, then we get one flow rate, and that flow rate we need to compare with the actual flow rate we measure by other methods, which is quite which is accurate lah. Because we are using one device, we want to know how accurate is that device, how accurate is that Venturi meter. We need to calculate the error. Okay, that's it.
Okay, sir.
That the all actually for other experiment next time, next few weeks, you need to learn everything also. I can choose randomly one to ask question. So you have to assign who is presenting experimental A, B, C, D or what. Then I choose maybe C. Then you present lah. Okay, and don't really need a lot of introduction. You can put there in case you want to show me when I ask about the theory part. Okay, but I don't want to listen. I just want to see your psychomotor, because this assessment is all about psychomotor. And then I guess that's it. You just send me the two YouTube link that I want. One is for demonstration, one is for presentation, and then you go and key in your attendance online.
Alright.
Okay, sir.
Okay,
If
sir.
no question, then that's all lah. Thank you very much.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay, bye bye.
Bye. Wait, sir.
Okay.
Where's the link for the attendance?